operator precedence parsing, if we talk about operator precedence parsing, then in operator precedence parsing, we can simply say that operator precedence grammar is a kind of shift reduce parsing method. It is a shift reduce parsing method, guys. It is a SR parsing method, and it is applied to a small class of operator grammars. It is applied to a small class of operator grammars. What are operator grammars? We will talk about when we will discuss a real example with you. When I will discuss a real example with you, I will discuss that what is operator grammars and how to find operator grammar. But if we talk about operator precedence parsing as of now, you can simply say that operator precedence grammar is a kind of shift reduce parsing, and it is applied to a small class of operator grammars. Now the main question that arises here is that what is operator grammar? So a grammar is said to be operator precedence grammar. Grammar, it is said to be operator precedence grammar if it has two properties. If it has two properties, what are the two properties? The very first one is no RHS of any production has epsilon. Means suppose I have written down like that, S derives AA, and if I write down S derives A or epsilon, so this grammar 1, it is operator grammar, but this grammar 2, it is not operator grammar. Why? Because the rule 1 is say that on the right hand side we don't need any epsilon production, and this epsilon production existed in the right hand side of the grammar. That is why it is not operator grammar. Now the rule number 2 is no two non-terminals are adjacent. Means if I write down like S derives AA, here if you will observe two non-terminals are adjacent. That is why it is not operator grammar. In order to make this grammar as an operator grammar, we make this grammar operator precedence grammar such that no two non-terminals should be adjacent. I will tell you that how to create operator precedence grammar with the real example, with the practical example, so that you can learn it better and you can solve it on your own. Now important note that you should have to take here is that operator precedence can only established between the terminals of the grammar. It ignores the non-terminal. Means operator precedence grammar, it only exists on the terminals. It only established between terminals, and it ignores the non-terminals, right? What is this theory? I will talk it in regard of the practical example so that you can learn it better. Now before that, just need to clear some more important concepts. The very first one is there are three operator precedence relations. What are the three operator precedence relations that are existed here is, suppose A is greater than B is written here. It simply means that this terminal A has the higher precedence than terminal B. It simply means that this terminal A is having higher precedence than terminal B. And the second rule, that is A is less than B, it simply means that this terminal A is having lower precedence than terminal B. Means this terminal B is having lower precedence than terminal B. In this case, you can say the precedence of terminal A is higher. In this case, precedence of terminal B is higher. And rule number 3, if this kind of symbols you will observe in the grammar, you can simply assume that terminal A and B both have same precedence. Now let's go to the next question. Now we are talking about operator grammar. I told you two rules. That what are the two rules of operator grammars? On right hand side, there shouldn't be any epsilon, and no two non-terminals are adjacent. No two non-terminals should be adjacent, right? So example 1, if I talk about example 1, you can observe it here. It is a operator grammar. Why? Because rule number 1, if you see rule number 1, no epsilon on right hand side, means it is follow. If I talk about rule number 2, no two non-terminals should be adjacent. Here it is a non-terminal, it is a terminal, it is non-terminal, okay, then it is non-terminal, it is terminal, it is non-terminal, and it is only terminal. So if you will observe here, you can simply say that if you will observe here, you can simply say that both the rules of operator grammar is followed here. Both the rules of operator grammar is followed here. That is why we can simply say that it is operator grammar. Okay, now next question is E derives EAE and ID, and next question is A derives plus and or star. So we need to answer that whether the following grammar is operator grammar or not. Whether the following grammar is operator grammar or not. So if you will observe E derives EAE and ID, you can simply say here that it is a non-terminal and it is again a non-terminal. Two non-terminals are adjacent. That is why rule 2 is not followed. That is why it is not a operator grammar. So how to make operator grammar, how to make this grammar as an operator precedence grammar? Simply replace this A with the next production rules. Means we have either plus as a non-terminal which can replace here, or we can replace it with this multiplication symbol here also. So in order to make this grammar as an operator grammar, I will write it like E derives E. On the place of A I will write plus and E. I can again derive A with star, so E star E, and simply I can write ID. So this was not my operator precedence grammar, but I converted it into operator precedence grammar by replacing adjacent derivable non-terminal with the terminals. So it is my operator precedence grammar. Why it is my operator precedence grammar? Because on the right hand side no epsilon is there, as well as if you will observe, this is terminal, this is non-terminal, this is non-terminal, this is non-terminal, terminal, non-terminal, and this is terminal. So no two non-terminals are together. That is why it is operator precedence grammar. So guys, are you getting the rules or not? Are you able to find the clear differences between the operator grammar, that which grammar is operator grammar and which grammar is operator precedence grammar or not? Please comment me in the chat box that are you getting the concepts or not, so that I can proceed with the next examples. Please answer me. Guys, please answer me that whether you are able to find the clear differences between operator precedence grammar or not, because it is very important to know that how to find operator grammar or not. Okay guys, now I am talking about next example. Okay, I feel very pleasure that you all are answering my questions. Now next question is, example is S derives S A S or A, and the A derives B S B and B. This is a complete grammar. Now guys, answer me, this grammar is operator grammar or not? This grammar is operator grammar or not? Answer me that this grammar is operator grammar or not. Example 3, answer me, this grammar is operator grammar or not? I am waiting for your answer. I am waiting for your responses in the chat box, that whether the following grammar is operator grammar or not. No, Nagarkoti has answered it correctly. Very good. No, it is not a operator grammar. Suyesh has also answered correctly. Piyush and Ankit also answered correctly that it is not a operator precedence grammar. It is not a operator precedence grammar. Are you able to get my sound, guys? Are you able to listen to me? Okay. So can we make this grammar as an operator grammar, guys? If it is not, okay, all answers are correct. I am getting answers from Jeevan, Poshali, Ankit, Piyush, Shuyash, Nagarkotti. So all your answers are correct. All your answers are correct, guys. Now next, can we make this grammar as this grammar is not an operator grammar? So can we make this grammar as an operator grammar? If yes, then answer me in the comment box that what is the correct operator precedence grammar for that. if it is not your all answers are correct that it is not a operator grammar. Correct, it is not a operator grammar. So how to make this grammar as a operator grammar, guys? Answer me that how to make this grammar as a operator grammar. How to make this grammar as a operator grammar? Answer me. Very good, very good. Replace A with B as B or B. Correct, correct, correct answer, guys. So my grammar was as derives. I am talking about example 3. Okay, that is this example I am talking about. As derives S, A, S and A derives B, S, B and B. So in order to make this grammar is not an operator precedence grammar because two non-terminals are adjacents. Two non-terminals are adjacents. So I will replace this A, the possibilities of A with B, S, B and B. So if I replace this A with simply S, B, S, B and S, and once again I can replace this A with this B, so it would be like SBS and then again it's A. So this grammar is existed now, and this grammar is my operator precedence grammar. Why? Because if you will observe here, it is a non-terminal, it is a terminal, it is a non-terminal, it is a terminal, and it is a non-terminal. So no two non-terminals are adjacents. Here as well, it is a non-terminal, it is a terminal, it is a non-terminal, and at last it is a terminal. So no two non-terminals are existed adjacently. That is why this grammar is operator grammar. Okay guys, so it is clear to all the candidates that how to find whether the grammar is operator grammar or not, because it is very important. Because in order to find that, in order to do operator precedence parsing, we must have to know that what operator grammar is, because we can only parse operator precedence parsing on operator grammars. If it is not operator grammar, then we cannot parse operator precedence parsing on it, right? Now I am telling one important concept with the help of an example. The question is, given grammar is given to us, that is e derives e plus e multiply with e and identifier, that is id, and input string is given to us, that is id plus id into id. Now the question is, apply operator precedence parsing on the given string. What we need to do, we need to apply operator precedence parsing. We need to apply operator precedence parsing. So it is very important, guys. Just focus on the screen, focus on the screen. It is very important part, that how to construct operator precedence parsing. It is very important topic. So just focus on the screen, that how to construct operator precedence parsing table for the given grammar. Now I am telling you, what we need to first to do is, it only revolves around terminals. It only revolves around terminals. So what are the terminals? Terminals, first would be identifier, would be one of the terminal. The next terminal is addition sign, that is plus. The next one is multiplication sign, and the last one is dollar. Dollar we need to include in the operator precedence parsing as a help for input string. So I need to write in on the column side as well as in the row side. I also need to write it like id, addition operator, multiplication operator and dollar. Now if I will make a operator precedence parsing table. If I will create operator precedence parsing table on it will look like that. I think you can clearly observe that how it can look like. These are the sets of terminals. They are the set of terminals. They are set of terminals in operator grammar, and they are also set of terminals in operator grammar. Okay guys, now one important topic here is that now we need to answer, now we need to find, now we will compare here. Is there any problem, guys, in my audio? Is there any problem? Actually today maybe internet connection, you may seem that internet connection may not be proper. I don't know why. Maybe due to network errors, guys. Okay guys, I am trying to holding it. I am trying to configure it, guys. I am trying to configure my voice. Okay, is it clear now, guys? Now can you able to hear me? Now can you able to hear me? Audio is lagging. Audio is lagging. Okay. Audio is lagging. Guys, can you hear me? Can you hear me? Is it okay or should I reset my internet connection, guys? Just give me 5 minutes. Is it okay or can I reset my internet connection? Please answer. Is it okay? Are you able to hear me clearly or should I proceed with the same internet connection or there is a need of improvement in it, guys? Yes, sir. Okay. So can I proceed with the construction of operator precedence parsing, guys? Okay. So if you will observe, we need to construct operator precedence parsing. We need to construct operator precedence parsing with the help of the grammar's terminals. So the very first rule is we need to compare between ID and ID, because by comparing we will fill this parsing table. So there is no comparison between ID and ID, so we will leave it blank. There isn't any comparison between ID and ID, so we will leave it blank. Now the next one is we need to compare the ID with addition sign. So basically this identifier have highest precedence. This identifier have highest precedence. That is why I will write it like this. This simply denotes that this identifier have highest precedence. Means on comparison of this ID and this addition mark, we can simply say that this this ID have higher precedence than this addition sign. Again, if we will compare this ID and this multiplication sign, then as I said that ID have highest precedence, so I will write this greater marks with the front of ID. And dollar basically have least precedence. Dollar basically have least precedence. Dollar have least precedence and identifier have highest precedence. Okay. Now if I will compare with plus and ID have higher precedence, so I will write it like that. If I will compare this addition sign with addition sign, so it depends on the grammar. It depends on the grammar that whether our plus sign is left associative or right associative. According to grammar, we can simply say that it is a left associative. So I am simply write here that it is a left associative. By default, we can treat plus as a left associative. But if our grammar is like that, T derives A plus T, that in that case this plus is right associative. Why? Because if you will observe, T is existed on the right hand side of this plus. T existed on the right hand side of this plus. So this addition sign is right associative. But if T derives T plus A, then this T is existed on the left side of plus. Then in that case we will say that this addition mark is left associative. So here if you will see E plus E, in that case by default we need to treat this plus as a left associative. So I am writing that this plus have a higher precedence, means it simply denotes that plus is left associative. If I compare between this plus and this multiplication symbol, you as well know that multiplication symbol have higher precedence, and as dollar is least precedence, so plus have higher precedence over dollar. Now we need to compare between this multiplication operator and identifier have highest precedence, plus and the multiplication have higher precedence. Multiplication here it is a left associative, so we will write it like that. And multiplication and dollar is least precedence, so we will make it like that. If we will compare this dollar with ID, then this ID basically have greater precedence. As you know, dollar basically have lesser precedence. Dollar have list precedence, because it is a notification of the input, that whether our input string is ending or not. It is the notification of ending string. That is why it is having list precedence, and we cannot compare between dollar and dollar. So it is our operator precedence table. It is our operator precedence parsing table. Guys, is it clear to all of you or not that how to construct operator precedence parsing table? Is it clear to all candidates or not? Please comment in the chat box. Is it clear that how to construct operator precedence parsing? Okay, it is clear to Nikhil. Very good. Very good. We simply make that how to construct operator precedence parsing. Okay, Soumya, it is clear to Soumya as well. Very good. Poshali, it is clear to Poshali as well. Okay, guys, good. Nagarkoti, very good, guys. So now we are moving that we have constructed operator precedence parsing. So I am again writing it here like ID, my plus symbol was there, multiplication dollar, and again I am writing here it ID plus dollar. Okay, so order of writing these terminals may vary, but precedence will not vary, right? So ID and ID don't have any comparison. ID and plus. It is my operator precedence parsing table. It is my operator precedence parsing table. Now the main question arises here that we have input string ID plus ID into ID. We need to apply parsing on it. What my input string is ID plus ID multiplication with ID. It is my input string. It is my input string. Now with the help of this operator precedence parsing table, I will construct parse tree on it. How I will construct parse tree on it? Just observe. It is my stack. With the help of stack data structure, I will parse this given input string on this stack. If stack is initially empty, why dollar and dollar input is different? No, it is no, we can't compare here and here we cannot compare. Is it clear, Soumya? It is, we cannot compare between dollar and dollar. It is blank. Okay, now at the initial state our stack would be empty. At the initial state our stack is empty, and I am writing dollar here so that it will notify me that input string is ended. Now here is a simple rule. Here is a simple rule. I need to compare top of the stack. Guys, you can make a note of it. I am dictating a very important point. To you. Please note it, because if you will forget this point, you will get confused that how to compare, whom to compare, and what to do. So just note an important point. Compare, just I am dictating, just take a note of it. Compare top of stack with current input symbol. What you need to do, you need to compare top of stack with current input symbol. What is my current input symbol? ID. Now I will compare this dollar with this ID. So if you will observe, if now I am dictating once again, if top of stack is list precedent, if top of stack is list precedent, then we will push the symbol, we will push the input symbol, push the input symbol into stack. Means I will compare this dollar with ID. So top of stack is dollar, it is list precedence than ID. because id have higher precedence and dollar have least precedence. So so guys, is it clear now? Am I audible or not? Today voice problem is occurring, right? So is it clear to or not? Is my voice is audible to all of you or not, guys? Is my voice is audible to you or not? Okay, clear. I don't know, maybe due to internet issues it may occurring, I don't know. Okay, so again I am repeating, my rule is simple, that we need to compare top of stack with current input symbol. So I will compare top of my stack element, that is initially my stack is empty. So I will compare this dollar. I will compare this dollar with top. Why make top of the stack? That is top of stack is initially empty, so it is dollar. I will compare this top of stack element with the current input symbol. The current input symbol is ID. So if you will see here, dollar is list precedence. So top of stack, if it is list precedence, if top of stack is list precedence, I need to push it. I will push it into the I will push this element into stack. It is rule number 1. Now I will move one pointer ahead. Now I will compare this plus with top of stack. What is top of stack? ID. ID is the top of stack. Now if ID is the top of stack, I will again compare ID with plus. So now top of stack element is higher precedence. If top of stack is a higher precedence, what I will do? I will pop this element. Pop means I will reduce this ID with E. Why I reduce this ID with E? Because this ID will reduce with E. This ID can reduce with E because E derives ID existed here. That is why this ID is now pop up. So I am again repeating here. You can simply see initially my stack is empty. So I compared this ID with this dollar. Top of stack element was laser precedence. So I pushed ID into it. At the next time I got plus sign. So this plus, when I compared it with the ID, when I compared this plus with ID, what I found, that my top of stack element is higher precedence. So what I did, I replaced it. I reduced this terminal with left hand side production, which was E, because my grammar is E derives E plus E or E star E or ID. That is why I replace this ID with E. Now I will, this is popped. Now this is popped off. Now I will again compare this plus with this dollar. If you will compare this plus with this dollar, top of stack is now laser precedence. So this plus will got push. Now it is push. So I will increment my pointer and now it is ID. If I will compare this ID with top of stack, again top of stack is laser precedence. Top of stack element is laser precedence because plus have laser precedence than ID. Plus have laser precedence than ID. So I will again push ID into top of stack and I will increment my pointer. Now if I will compare this multiplication symbol with ID, you will simply observe that top of stack is now having higher precedence. Why? Because when I will compare ID with multiplication, ID is having higher precedence. That is why we can simply say that we need to perform pop operation. When I pop this ID, I will replace this ID with left hand side non-terminal. Why? Because this ID is popped off from the stack. That is why it is replaced with capital E, that is non-terminal E, according to our grammar rule. Now again I will compare this star with this plus because this is popped now. So I will compare this multiplication operator with this addition operator. If I will compare them, you will simply observe here that the multiplication sign have, that is this plus symbol have laser precedence. This plus symbol, this is the addition symbol, it is have this addition symbol have laser precedence than multiplication symbol. So I will push this multiplication symbol in the top of stack. Now I will increment my pointer and I will compare this ID with plus. So this id and multiplication symbol will compare, and again top of stack is lesser precedence because multiplication have lesser precedence than id. So I will again push this id into top of stack and I will increment my pointer. When I will increment my pointer, I will observe that dollar is at the last position. So it signifies me, it indicates me that my input string is ended. My input string is ended. Now what I need to do, if my input string is ended, one by one I will pop off my state, pop off the elements. How to pop off? Now I need to compare this dollar with this id. Top of stack has higher precedence, so this id will pop off. So if this id will pop off, this id will replace with capital E. This id will replace with capital E. I am changing the color of my pen so that it cannot confuse to you. Right now I popped up this id again. So I popped up this id at the first position, which was this. I popped up this id at the second position, which was this. I popped up this id at the third position, which was this. Now I will compare this dollar with the multiplication symbol. So this dollar and multiplication symbol, if you simply say that top of stack have higher precedence, so top of stack has higher precedence, so I will replace this multiplication symbol here. So this e multiplication e will be there and it will give me this e. Okay, so at the fourth position, at the fourth time I replaced this multiplication symbol. Now I will compare. So this is popped up, this is popped up, this is popped up. And if I will compare this dollar with the top of stack, so what is at the top of stack now? At the top of stack I have addition symbol. So top of stack have higher precedence, so again pop up this plus. So I have popped up this plus at the fifth position, so I will pop up this position at the fifth step, and this will lead to me. So how my parsing, how my parse tree is looking like: e, this e derives e here, and then this e and e derives e. This is my parse tree. And if I popped up this, what is at the top of stack? Top of stack is dollar, and I am getting dollar. When I get at the top of stack dollar and at the input symbol also dollar, then I will check that at the upper side I am getting starting symbol again. So if I get starting symbol at the uppermost side as well, it means that it is accepted. Means at the end position of an input symbol, if I got dollar, and if my stack is again empty by pushing and popping operations, so this parse tree will be generated from this grammar. And at the highest position, if I got my starting symbol, I can simply say that it is operator precedence grammar, and I have accepted my string. So my string, what was my string? id plus id into id was accepted, and it will create such kind of parse tree. So guys, we have generated this parse tree from bottom to top. So it is bottom up parsing, and we have generated it from right to left, because first right side element have generated, then left side element had generated. So this is the last technique of bottom up parsing, that is operator precedence parsing. So guys, is it clear to all the candidates or not? Now comment me that how to construct operator precedence parsing, how to construct a parse tree, how to accept the string using operator precedence grammar. Just answer me, is it clear to all candidates or not, that how to construct operator precedence parsing table? Please answer me. Is it clear to every candidate or not? Clear, very good. It is clear to Soumya, very good Soumya. Is it clear to other candidates as well or not? Please answer me. Okay, Nagarkoti, clear to you, very good. Guys, if it is clear to you, next question I am giving to you, you need to solve it. Is it okay? But before that, let me do one more thing on it. Okay, Poshali, very good, clear to you, right? So my string here was, in this question my string was id plus id into id. Okay guys, and I have generated this parse tree. Now suppose my string is id plus id plus id. For example, this is my input string now. So once again I am telling you, after that you need to solve questions guys. Once again I am telling you, After this question you need to solve the gate questions. Okay, so just focus once more. If any candidate didn't got how to construct parse tree operator precedence table, then just focus once again. At the initial symbol we have dollar in the top of stack. If my string is at this time is id plus id plus id, so I will compare id with the dollar. At the current input symbol id is there, so top of stack have a lesser precedence, so push. If top of stack has lesser precedence, push. Now I will compare, I will increment pointer, my pointer is now plus. It is in this time this plus will be get compared to id. Now top of stack have higher precedence, so just replace this id with e. So at the first position I have replaced this id. In first transition I have replaced, means it is my first replacement. Now I will compare this plus with dollar. So again top of stack is lesser precedence, so I will push this addition operator into the stack and I will increment my pointer. Okay, now again I will compare plus with id, and this id is now having higher precedence, so it will push into the stack. Now plus, this plus, that is input symbol is higher precedence, so this id will get pop, it will be replaced with e. And again I will compare plus with plus. So if you will observe here, if I compare this plus with plus, it is left associative according to our grammar. So if it is left associative, means our this plus is more precedence, means it is having higher precedence. If it is having higher precedence, means we need to pop out. If I will pop off it, it will simply mean that e plus e is generated e here, because left associative, my plus is left associative, that is why this is popped off. Now I will compare this plus with dollar. Now plus have higher precedence, so plus will get pushed off, and plus and id will get compared. Now id is having higher precedence, it will be pushed off, and I am coming to dollar. Now dollar will get compared to id. Top of stack is having higher precedence, so in this time, at the fourth time, this id will replace with e. This is popped off, and this dollar is now compared with plus, so this e plus e will be there, and it will lead to starting symbol e. Now this is popped up, this is popped up, this is popped up. At the last, dollar and dollar get compared. After completion of this, you can simply say that this e plus e generated e first, and after that this e is added to this. This is the scenario, means if id plus id plus id will be provided to my compiler, my compiler will add this one first. After the result of this one, it will add that result to this id. So this is the rule which we have followed according to our grammar. So I hope this is clear to you now, that how to construct operator grammar, how to make operator precedence parsing table, and how to generate parse tree, how to accept our input string, and all about operator precedence grammar. Guys, is it clear to every candidate or not? Please comment me so that I can move to our next question, which is a gate question, and you will solve it. Is it clear to every candidate or not, that how to construct operator precedence parser table, and how to solve such kind of questions? Clear? Very good, guys. Very good. Very good. Very good. Okay, so I am giving next question to you. The question is in front of you. The question is in front of you. My question is very simple. The question is, just 2 seconds. Okay, just question is construct. My question is construct operator precedence parsing table. Construct operator precedence parsing table for the following grammar. For the following grammar, you need to construct operator precedence parsing table. Construct it, guys. Construct it. And if you are facing any problem while solving the question, you can ask me in the chat box. I will solve your problem, guys. Don't worry, I will solve your problem. But first you need to do according to yours. Apply all the concepts and approaches which I have discussed with you. If it is not a operator precedence grammar, make it operator precedence grammar, and then apply the rules of operator precedence parsing table. And if you have constructed operator precedence parser table, just comment done, so that I will discuss its solution in detail. So I am giving you 5 minutes here, guys. 5 minutes to answer this question. Just try. What you need to do, I am telling you steps. At the first time you need to observe the grammar. In second steps, if it is a operator precedence grammar, it is okay. If it is not a operator precedence grammar, make it operator precedence grammar. And in third step, if it is a operator precedence grammar, try to compare all the terminals and assign the precedence power of each and every terminal in the operator precedence parsing table. So I am giving you 5 minutes to answer this question, guys. I am expecting every candidate to answer. Just solve it now. If you have done with the solution, please comment done, so that I can move to the next solution. I can move to the solution. I can discuss the solution and we can move to the next question. So guys, if you have answered this question, if you have solved this question, please respond in the chat box so that I can proceed for its solution. Are you solving it, guys? Are you solving this question or not? Okay, okay. So construct operator precedence parser for that. Sir, couldn't understand how to proceed because previous example had one grammar rule. This had so many. So Soumya, you just need to focus on terminals. How many terminals are there in this? You only need to answer this question on the basis of terminals. How many terminals are there? Because while constructing operator precedence parsing table, you just need to compare terminals. Okay, you just need to compare terminals. You just need to compare terminals. This W is, guys, okay. This W is a non-terminal, guys. This W is a non-terminal. Okay, W is a terminal. Okay, no worry, guys. All W's are non-terminals guys. All W's are terminals. This W leads to L strong W. These all are terminals. These all are terminals. Now I am discussing the solution guys. Just focus here. This grammar is not a operator grammar. At the first stage, if you will observe, in the first stage, if you will observe, this grammar is not a operator grammar, right? If this grammar is not a operator grammar, what we need to do? We need to make this grammar as operator grammar. So I will replace this R with BSR. So what I will get? S B S R, and then I am getting S, but you will say that here SR would be there, and again I am getting SR. It is a recursively defining paragraph, because if I am again replace this R, I will again get SR. If I will again replace this SR, I will again get SR, isn't it guys? If I will replace this R, I will again get SR. So this is called as recursively defining paragraph. This is called as recursively defining paragraph. In that case, what I need to do, I need to replace this SR with P. So I will write this as S B P. I replace this SR with P and S here. Next rule is, and if I can also replace this SR with BS, so I can write it as a S, and if I will replace this R with BS, I will get SBS, and at last I have S. It is my first transition. In next, I will say that R, I do not need to write any R here because I only have P. So this is my redundant statement because I don't have any R in that. So I will remove this. I don't need this. Now I will just write S derives W, B, S and W. And in next I will write W derives L string W and L. And in next I will write it L derives ID. So this is my operator grammar now. It is my operator grammar. It is my operator grammar guys. Now how many terminals I am getting? How many terminals I am getting? One terminal is ID. One terminal is ID. Another terminal is multiplication sign. Another terminal is multiplication sign. I will add here. What is another terminal is B. This B is another terminal I will take here. What is another terminal? W. W is my another terminal. And at last what I am getting? Dollar. Dollar is my another terminal. So guys, these are the terminals. Okay, these are the terminals. Now I need to compare ID and ID will not have any compare, and dollar will not have any comparison. Now if I will compare ID, basically ID have highest precedence. It is a rule that ID have highest precedence among all the terminals. So I will simply fill this table until now. And this dollar have least precedence. This dollar have least precedence from all. This dollar have least precedence from all terminals. So this table I have filled like that from until here. Now I need to compare this star with this star. So if I will compare this star with this star, guys tell me, this star is left associative or right associative? I am asking from all you candidates. Answer me. This multiplication symbol is left associative or right associative? Answer me. After that I will tell you. हेलो 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 फूफा जी, मैं वो ऑनलाइन क्लास ले रहा था यहीं से घर से। मैं वो क्लास ले रहा था, क्लास ले रहा था यहाँ पे घर से ही। चल रही वो मेरी 7 बजे तक क्लास है। हाँ तो वो दीपक तो आ रहा, दीपक निकल गया शायद इधर से वहाँ के लिए। हाँ हाँ जी हाँ 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 मिल हाँ हाँ ठीक है हाँ हाँ। Right associative. Very good, guys. Very good. So you have answered me right associative. Why it is right associative? If anybody don't know that why it is right associative, you can answer it like L W derives L is multiplication W. So this W, this terminal W existed. This W existed on the right hand side of this multiplication symbol. This left hand side production is existed in the right hand side of this multiplication symbol. That is why this multiplication is right associative. So if it is a right associative, I will give precedence here. Now if we will compare multiplication with these two, so multiplication basically have higher precedence because they are operators and they are constant, so operators have higher precedence, right? Now if I will compare B with multiplication have higher precedence, and B. So guys, tell me, this B is there, so it is left associative or right associative? It is again right associative because this S existed on the right hand side of B. That is why this B is again right associative. Okay guys, now there is a great confusion I think you guys are facing this, how to compare this B and W. So if you will compare, B is here and W is here and W is here. So if we will compare this B to this W, it will not result anything. But if you will compare this B with the lower side W, so whatever terminal existed at the lower side, whatever terminal existed at the lowest side, whatever terminal existed in the lowest side, basically that have higher precedence. Id basically existed in the lowest position, that is why it is having highest precedence. So in that case, W is having highest precedence. So W is having highest precedence, so I will write it like that. W is in multiplication, and W multiplication symbol is the operator, it is having higher symbol. B and W, so if you will compare, B is on the upper side and W is on lesser side. So if it is existed in the lowest side, it is having higher precedence. And if I need to compare this W and W is right associative, so I put it like here. So guys, this is the operator precedence parsing table for the following grammar. Is it clear to all candidates or not? Answer me. Is it clear to all candidates or not? Please answer me. If you have any kind of doubt, if you guys are facing any kind of doubt in this operator precedence parsing table, please comment me. I will try to solve them. Don't worry. Is it clear, guys? Okay, red part again. Nagarkote answered that. Sir, B and W. Okay, I will compare B and W again. Don't worry. Okay, many candidates are facing problem in red area. Don't worry. Now I am comparing between B and W for terminals. If there are multiple terminals, guys, make a note. Guys, make a note. If there are multiple terminals, then what terminal existed on the lower side have higher precedence? Whatever terminal existed in the lowermost side, having highest precedence. So you observe here, this W, basically we first need to compare this B and W, but they are on the same level, so we cannot deduct any conclusion here. So for deduction that whose precedence is greater, we need to go somewhat in the lower side. So W is existed in the lower side here. So we can conclude that this W is having higher precedence than B. Why? Because in the grammar, this W existed on the lowest side, because this transition existed in the lowermost side and this transition existed on the uppermost side. So whatever transition existed in the lowermost side, if we find any terminals in that, we can directly say that it have higher precedence. That is why this W is having higher precedence. ID further have somewhat lower level than this W, so this ID will have highest precedence because it is in the lowest side. It is in the lowest side of the transition. Okay guys, now as this W is existed in the right side of this multiplication, that is why it is a right associative. This B is, this S existed in the right side of this B. That is why this B is also a right associative. So guys, is it clear now or not? Is it clear to all of you or not? That why W have higher precedence over B, and why W is right associative and why B is right associative. Is it clear now? If it is not clear, don't worry, I will tell you once again. But ask me doubt. If you really have doubt, I will explain it again. Is it clear, guys? Good. It is clear to Nagarkoti, Nikhil. Very good, guys. Soumya, is it clear to you or not? Or should I explain it again? Ashik, it is clear to you. Very good, guys. Very good. So is it clear to all the candidates or not now? Soumya, is it clear that B and W? Sir, B is right associative for, because there isn't any terminal, so B is right associative for this S, because the leftmost symbol of this transition in which this B existed is S. That is why this is right associative, because from this transition we can't derive, because here P is there, so P is there, so B, this P existed on the rightmost side, and here S is there, so we cannot deduct anything about B from here. We can only deduct anything from B here, that this S is directly saying that this S existed on the right side, that is the left hand side production, left hand side non-terminal existed on the right hand side of this B. That is why this is right associative. This transition deduct that the small b, that is terminal B, is right associative. Is it clear now? Sir, star have higher precedence than B and W. Yes, because star is in the lowermost position. Nagarkoti, star is in the lowest position than B. That is why it is higher position, because this star is having in the lowermost position. Suppose I added one more transition here. Suppose I will add one more transition, that L derives L plus L. In this grammar, if I will add one more transition, that L derives L plus L, then you will say that this addition sign have highest precedence. This addition sign will have highest precedence in these terminals. Why? Because this addition symbol, this addition operator is in the lowest side. It is in the bottommost position. So if I will add this transition now, you will say that this plus will have highest precedence, because it is in the bottommost side. Is it clear to all candidates or not now? Is it clear? Whatever in the bottommost side of the transition will have higher precedence in case of terminals. Clear? Very good, guys. Very good. Now we will directly solve important questions of GATE. But before that, do you want any 5-minute break, guys? If you want, do me comment so that we can take 5-minute break and we'll continue following slide later. Do you need 5-minute break or should I continue, guys? Because it's more than 1 hour since we have started our today's session. Okay, so guys, it's 5-minute break I am giving.